Hi everyone, my name is Howard Shea. My two group mates are Utsav Munendra and Arelys Navarro. Uh, our project is WebAssembly for Arduino or Mbed OS. So our goal of this project is to develop a sensor interface that would allow for WebAssembly micro runtime to run on our Arduino. And using this runtime, we can run WebAssembly applications. Now, our specific aims are first to run WAMR on Zephyr RTOS. Next, we port WAMR to Mbed RTOS. Then we run WASM WebAssembly program on our micro runtime, which is on this Mbed device, such as our Arduino. And finally, we can evaluate the program running speed and memory overhead of WAMR versus no WAMR. And our technical approach for this project would be to first running Zephyr with WAMR. Next, we aim to port WAMR to Mbed OS. And we do so, it's a little more complicated because WAMR is not supported on Mbed OS. And so we have to implement the platform API layer ourselves. After implementing the layer, we can compile WAMR. And finally, in order to evaluate it, we would run our programs on there, predefined programs, and we can see the different speeds that it takes to run and how much memory is being used.
Hello, I'm Utsav Munendra and I'll give an update on the current status of the project. First, we wanted to set up a baseline for us to learn more about how WAMR works and in what ways it uses its various components. For that, we have an RF52840 development kit board which runs ZephyrOS. And since WAMR fully supports ZephyrOS already, we wanted to have a running WAMR interpreter on that board. However, our path to setting up the development environment to compile and flash to the board with Zephyr was not as straightforward as we expected. On my Windows machine, the cross-compilation toolchain was incorrectly calling the linker to link exit function to the host machine's libraries instead of the libraries which would be on the board. This issue is being fixed right now, and after some trial error with the advice of the developers on the Zephyr Slack channel, I was able to find the root cause of this and I downgraded CMake to fix it. Additionally, I found that the guide was missing a few instructions, so I submitted a pull request regarding that too. With all of that done, we now have a development environment set up to compile and flash programs to a board running ZephyrOS. Then we finished getting the WAMR interpreter to be compiled and flashed to the board. Again, the instructions on the public repo were missing a bunch of dependencies and assumed some file structure which was not obvious, but I was able to dig through the CMake error logs and resolve each issue. We right now have a WAMR interpreter running a WebAssembly program on the NRF 52840 DK board with ZephyrOS. I've also submitted PRs to improve the guide wherever I felt necessary, and those will be available in our project repo if they get merged. So currently, we are focusing on porting the WAMR interpreter to Mbed OS. WAMR also provides a ahead of time compiler and a just in time compiler, which we might be able to explore after having a working WAMR interpreter on Mbed setup. We have gone through the porting guide and identified which files are needed to link which set of functions between WAMR and Mbed OS. Additionally, since Mbed is POSIX compliant and since it already has math.h library functions available, we only need to provide the Mbed platform specific definitions. We also need to create a CMake building script for Mbed, and we need to code the API used by WAMR, which are part of the platform abstraction layer, all of which is what we are currently working on right now.
All right, so thanks, Utsav. Again, my name is Arelys, and I will be going over the next step. So one of the first steps I will be taking is working on porting Wasm micro runtime to a different OS. So this is generally called WAMR. And with the device OS that we want to apply this to is Mbed. So it's not one of the already established platforms that has been set up, such as Zephyr. So we have been able to identify missing and pre-existing interfaces so that we can set up the appropriate folders and such. Additionally, once we have that established, we need to confirm that we can control the I/O pins with our Arduino Mbed application. We've taken a couple steps ahead in this area as well by having our C program already written, which is going to be able to control the I/O pins. So this is really just a matter of establishing the porting and then getting this code that's already been prepared running. Once everything is running together smoothly, we want to make sure we are running timing analysis and also running memory overhead analysis. This is to compare results of just running this application by itself versus WebAssembly and to make sure that there isn't any slowdown in terms of the micro runtime running with it. We want to be able to point out areas where there might be room for optimization if there is room for it. Although we know that WAMR has been very successful in speeding up the process and making sure that it's not actually slower than compiling without WAMR. But we want to make sure that we analyze this and have some data to really quantify our results for this. So overall, these are our next steps for our project, and we look forward to working on this a little bit more and possibly in the future, even running different programs that are a little more complex if time allows. So again, thank you for listening to our presentation, and thanks.